What are the different types of loads the structure has to resist? I know self weight because I always measure my weight every week. So there is a self weight, but other than that, what are the loads? And according to its types, like how they are placed. Oh, we need to study about the different types of loads on the structure. So, in the today's video, we will see different types of loads according to its origin, that is, dead load, live load, and all the different types, and the loads according to their application method. So, let's watch today's video. Engineering Fundamentals from the Appendix B, page number B-6 to B-8 from the manual Detailing for Steel Construction by AISC and NIST by Yugandhara Tadele. Content of the today's video: Introduction, Loads, Classification by Origin and Classification by Type, and Summary in the end. We have seen types of supports in the structure and types of members. There are separate videos for this topic. Please watch those videos before for better understanding. The link for those videos is provided in the description box below. Loads. The main purpose of steel structure in a building or bridge is to support loads. Loads are the forces that the structure must be designed to support. Engineers' first step in a structural design is to define the loads that the structure must support. There are three main types of the loads on buildings: dead loads, live loads, and loads produced by forces of nature. Loads are defined by building standards such as ASCE 7-0. Dead load. It is the actual weight of the structure. Dead loads include things like architectural features, HVAC system, electrical systems. Live loads are the load created by the occupancy of the building. These generally include human occupancy and the structure's movable content. Sometimes these loads are very accurately defined. Example: volume of an elevated water tank determines the weight of the water in the tank. However, some live loads, especially human occupancy loads, are not easily defined by forces of nature. These include wind loads, earthquake loads, ice, and rainwater loads. Extensive work has been done in the areas of wind and earthquake loads to develop load models. Loads can also be classified by type based on how the loads act on a structure. Figure shows a schematic representation of a load, that is uniformly distributed load over the full length of the beam. This load could be caused from the weight of the floor, decking, or distributed live loads. Since each 1 feet length of beam carries 100 lb share of the load, so load is labeled as 100 pounds per foot, or zero point 0.1 kips per foot, or zero point 0.1 k per foot, where 1 kip equals to 1000 lb. Symbol small w is used to denote uniformly distributed load across the full length of the beam. The resultant capital W of the distributed load is the load intensity, that is load per foot multiplied by the loaded length in feet, that is 100 lb per feet into 10, that is 1000 lb. The resultant is placed at the center of the loaded length, that is here at the midspan. This resultant is used to compute the beam reaction. The figure shows the examples of uniformly distributed load, that is a man lying on a bench and wall on the beam. This is the small w pounds per feet. The roof beam designed to support hoist and roofing spread over full length of the beam might not be able to support the bundled weights of this material if they were placed at the middle of the beam during construction. This is the another type of load, that is concentrated load at midspan. Its magnitude is 1000 pounds, that is 1 kip. The girl sitting on the bench is the example of concentrated load at the midspan. The figure shows the uniformly distributed load on a portion of the beam length. Here, this uniformly distributed load is for 5 feet length of the beam and its magnitude is 200 pounds per foot. So, it is converted into a concentrated load resultant, and it is placed at the center of the loaded length. Its resultant is 200 pounds per foot into 5 feet. The loaded length is equal to 1000 pounds. This is how the off-center concentrated load is shown. It is the magnitude of 100 pounds at 2 feet from the support A. Off-center concentrated load. The girl sitting on one side of the bench is the example of off-center concentrated load, and cross beam connected to the quarter point is an example of this type of load. Figure shows the inclined concentrated load at the midspan. Its magnitude is 1250 pounds. In the next video called Equilibrium Concepts, we will see how to calculate its horizontal and vertical components and resultant reactions at supports. These are some of the examples of inclined concentrated load at midspan. For this beam, here will be the inclined reaction, and for this beam, this is the inclined reaction. Summary. We have seen loads called dead load, live load, snow, earthquake, wind and rain loads, and the loads based on its type, such as uniformly distributed load and concentrated load. In the next video called Equilibrium, we will see how to calculate reactions for these types of beams. Thank you so much to you all for being with me throughout this video. I am grateful for your support. Happy learning! This is the AIC committee who prepared the manual detailing for steel construction. I am grateful to them. Thank you so much, the committee. If you find this video useful, then please share. It will help others. And subscribe to get notified about the new videos.